In this lecture, we'll take a look at a couple more examples of algorithm design. The next problem we'll take a look at is what we call big, bigger, biggest. The next problem we're going to take a look at doesn't involve searching a list of names, but instead we're going to search a list of numbers. And what's nice about this is we can use this algorithm for solving several types of problems that involve lists of numbers. For instance, we can try to find the largest value. So if we have a list of values, a list of numbers, we can search through there and pick the largest one. We can also use the same approach for finding the smallest value. We just search every single number in this list, pick the one that's the smallest. And we can use these algorithms as building blocks for solving more complicated, more complex problems. So like for example, if we want to find the largest or smallest value, we can use that to help with sorting a list of numbers. Because remember, in our earlier example, we had a list of unsorted items. So one thing we could do is try to find the smallest one and put that in a particular spot, or find the largest one and put that in a particular spot. So we can use these algorithms as building blocks, or what we would call subroutines, to help us with much larger algorithms. So here's our official problem that we're trying to solve. So let's say we have some value n, and it's greater than or equal to 1. So it's at least 1. And then we have a list of exactly n unique numbers. And we're going to label these A1, A2, all the way to AN. We want to find and print the largest value in the list and where that value is in the list. So we're going to keep track of the position in the list where that value occurred. So just to give an example, let's say we have a list, 19, 41, 12, 63, and 22. Notice that this list is not sorted. I mean, we can deal with sorted or unsorted, but right now we're just have some arbitrary list of numbers. In this case, n is 5 because we have 5 items in the list. And what we would want to do is find the largest value. In this case, that value is going to be 63 over here. So we're going to print 63, and since this is the 4th value in the list, we would also print position 4. The way we're going to handle this approach is somewhat similar to searching for a name in a list. We need to look at one number at a time. And what's going to happen in this case, if the list is unsorted, we're going to be looking at every single number in the list. And that's okay. So what we're going to do then is we'll assume that the first number is the largest. Because think about this in terms of a computer. It cannot look at all the numbers at once. For us, we can just see the entire list ahead of us, and we can just pick the one that's the largest. A computer can only look at one value at a time. So we're just going to assume that the first item is the largest. It may be the largest, it may not end up being the largest. That's okay. But what we'll do with this value is we'll store it in a temporary location. And for our purposes, we're going to say it's the current largest number. So we'll say, okay, pick the first item, we'll assume it's the largest, put it in some temporary value, which we'll call current. So then we're going to compare the next number in the list to what we consider as the current largest number. So if the current largest number is larger than the second number, then nothing changes, because that value is still the largest among the two values we've looked at so far. Now, if the second number is larger than the current largest number, well, the current largest number is no longer the current largest number. So instead we replace the current largest number with that second number. So that second number now becomes the new current largest. And then we just repeat this for each number in the list. So we'll take a look at the third item and we'll compare it with the current largest. If the current largest is still larger, then nothing changes. But if the third value is now the largest, we change what's in their current largest. We update it with the third value. So basically what's happening is for each step, for each value we look at, so for the ith iteration of this, we technically have the current largest value of the first I items. So when we get to the end of the list, we're going to have the largest value among all n items. Now that we have a general idea of what our algorithm is going to look like, we need to start coming up with the actual steps. So let's deal with the initialization part first. So the very first thing we need to do is figure out the list. So we need to ask for n, which is the size of our list, and we need the values of the list, A1 all the way up to AN. So it's going to be kind of hard to find the largest value if we don't have the list. We also need to set the current largest value to A1, because remember, we're saying we're going to pick the first value and assume that is our current largest. So we need to create our current largest variable and assign the value of A1 to that variable. We also need a second variable, which we're going to call location, to keep track of where the largest value is in the list. Because remember, not only are we going to print the largest value, but we're going to print where that value is in the list. So as we update our current largest value, we also are going to need to update our location variable. Now that we got the initialization part taken care of, how do we actually go about coming up with the steps for finding the largest value? Well, to simplify our algorithm, we can use a loop to look at each value in the list, just as we used a while loop to look at each name in our phone book. So just as we did before, we're going to need some counter variables, so we'll use I in this case. It's a very common variable to use for counting things or going through items in a list. So in this case, if AI is greater than largest, then that means here largest is our current largest variable. Then that means we need to update largest and location. So largest will be set to AI and location will be set to I. So that means that we found a value that's larger than our current largest. Now, if that's not the case, we don't need to do anything to largest or location. But this isn't really necessary to say in our algorithm. Just to have an instruction that says don't do anything is kind of unnecessary. So we're just going to omit that part. So what we're going to see later on is in our algorithm, there's not going to be an else portion to it. So if it's just not true, we'll just skip on and go on with the rest of the algorithm. And that's pretty common as well, so there's no issue there. So then we need to repeat all these steps for each item in the list. So we look at the item, compare it with largest. If AI is greater than largest, we update largest and update location. If it's not, then we're just going to move on to the next item. And whether or not it's larger or not, we're still going to keep going to each item in the list. So we just need a way to repeat all these items. So that means we are going to have to use that loop. And we need to make sure that we stop after we read the last value because we don't want to go beyond the list. We got to tell the algorithm when to stop. So here is the complete algorithm for finding the largest value. So the first couple steps deal with the initialization. So step 1, we're going to get the value for n, which is our size of the list. Step 2 is to get the values of the list itself. Step 3 is to initialize the value of largest to A1. And step 4 is to initialize the value of location to 1. And then step 5, we're going to initialize our counter variable I to 2. Now you may think, wait a minute, shouldn't we just initialize it to 1? But remember, we've already taken care of A1. That's our current largest. So we don't need to start at A1 anymore. We're going to start at A2. So then steps 6 through 11 take care of our while loop. So while I is less than or equal to n, so as long as we're still in our list, we're going to go to step 7, which will check to see if AI is greater than largest. If so, then we're going to set our largest to AI, and we're going to set our location to I, because the next item we looked at is in fact larger than our current largest. And then after that if statement, regardless of whether it's true or not, so notice at step 10, we're going to add 1 to the value of I, regardless of whether we do steps 8 or 9 or not. Because if it's larger, then we'll update and then we add 1 to I. If it's not, then we're still going to add 1 to I because we need to take a look at the next value in our list. So that takes care of our loop. So once we've gone through that loop until we get to the end, we'll go to step 12, which will print out the values of largest and location. And then we stop, and that's our algorithm.